Writing error messages to standard error instead of standard output. At the moment, we're writing all of our output to the terminal using the printline function. Most terminals provide two kinds of output: standard output, stdout, for general information, and standard error, stdir, for error messages. This distinction enables users to choose to direct the successful output of a program to a file, but still print error messages to the screen. The printline function is only capable of printing to standard output, so we have to use something else to print to standard error. Checking where errors are written. First, let's observe how the content printed by minigrep is currently being written to standard output, including any error messages we want to write to standard error instead. We'll do that by redirecting the standard output stream to a file while also intentionally causing an error. We won't redirect the standard error stream, so any content sent to standard error will continue to display on the screen. Command line programs are expected to send error messages to the standard error stream, so we can still see error messages on the screen even if we redirect the standard output stream to a file. Our program is not currently well behaved. We're about to see that it saves the error message output to a file instead. The way to demonstrate this behavior is by running the program with the greater than symbol and the file name output.txt that we want to redirect the standard output stream to. We won't pass any arguments, which should cause an error. The greater than syntax tells the shell to write the contents of standard output to output.txt instead of the screen. We didn't see the error message we were expecting printed to the screen, so that means it must have ended up in the file. This is what output.txt contains. Problem parsing arguments, not enough arguments. Yep. Our error message is being printed to standard output. It's much more useful for error messages like this to be printed to standard error, so only data from a successful run ends up in the file. We'll change that. Printing errors to standard error. We use the code in listing 1224 to change how error messages are printed. Because of the refactoring we did earlier in this chapter, all the code that prints error messages is in one function, main. The standard library provides the ePrintline macro that prints to the standard error stream. So let's change the two places we're calling printline to print errors to use ePrintline instead. Listing 1224, writing error messages to standard error instead of standard output using ePrintline. After changing printline to ePrintline, let's run the program again in the same way without any arguments and redirecting standard output with a greater than symbol. Now we see the error on screen, and output.txt contains nothing, which is the behavior we expect of command line programs. Let's run the program again with arguments that don't cause an error, but still redirect standard output to a file, like so. We won't see any output to the terminal, and output.txt will contain our results. This demonstrates that we're now using standard output for successful output and standard error for error output as appropriate. Summary. This chapter recapped some of the major concepts you've learned so far and covered how to perform common I/O operations in Rust. By using command line arguments, files, environment variables, and the ePrintline macro for printing errors, you are now prepared to write command line applications. By using the concepts in previous chapters, your code will be well organized, store data effectively in the appropriate data structures, handle errors nicely, and be well tested. Next, we'll explore some Rust features that were influenced by functional languages, closures, and iterators.